Okay, let's take a look at Unit 6, Lesson 13, Amplitude and Midline. So 13.1, we're comparing these parabolas. And so the first one, we're matching each equation to the graphs. The first one is y equals x squared. So our vertex is at the origin. So it's got to be either A or B. And then we also know that the ordered pair 1, 1 is going to be on that graph. And if you look here, that is not 1, 1. And so it's got to be B, where you can see 1, 1 is there, right? So this is y equals x squared. That is also called the parent function because all the other graphs come from that one. So y equals 3x squared. Again, your vertex is going to be at 0, 0. And so that has to be A. Also, you can see that A is a little bit stretched vertically from B, and that's what that 3 in front of the x squared does. And we learned that back in transformations of functions. And then for number 3, we know that we have a horizontal shift to the right 1 unit. So that's going to make our new vertex 1, 0. And we still have that stretching. So it's going to look similar to A, but be shifted to the right 1 unit. So that makes our answer E. All right, then if you take a look at number 4, we have y equals 3x squared. So we have that vertical stretch, but then we also have minus 1 there. So that's going to take our vertex to 0, negative 1, because we're shifting down. So that's going to be D. So this one is y equals 3x squared minus 1. And then finally, the last one, y equals x squared minus 1, is a shift to down. So that vertex is also going to be at 0, negative 1. But it's like the parent function in that it's not been stretched at all. So that one is C. So that's y equals x squared minus 1. All right, let's take a look at 13.2, blowing in the wind. And so we've got a windmill that has a radius of 1 meter. So our radius is 1 meter. The center is at 0, 0. And it's on a coordinate grid. So we're writing a function describing the relationship between the height, h, of w and the angle of rotation. So remember that the height, so as the angle, or as the blades rotate, so let's say w has rotated up here, then we have this right triangle. And so we are looking at the height. Well, that's the opposite side, so that's going to be sine. So h equals sine of theta, right? Because there's our right angle. So then number 2, we're going to describe how our function and its graph would change if the windmill blade was 3 meters. So instead of being 1 meter, if it was 3 meters, that's going to extend all of this by a scale factor of 3. So what happens is h is equal to 3 times the sine of theta. So we are changing that, that height by a factor of 3. And then if we look at the graph, and let's get rid of some of these graphs. We got sine, well, there's my sine of theta. And if I put a 3 in front of that, there you can see that we have changed the height of our graph, and that's called the amplitude. So when we multiply our function by a number, that's changing the amplitude. And in this case, that amplitude is 3 because the amplitude is the distance from the midline, which here is the y-axis, I'm sorry, the x-axis, right? And so your midline is y equals 0. And the distance from the midline to a maximum or a minimum, in this case, is 3. In the original, it was 1. All right, and then if we take a look at if the blade length is 0.5, so that's y equals 0.5 times sine of theta. And you can see now that it got shorter. So we have h equals 0.5 sine of theta. And so now our amplitude is 0.5. And the midline is still 0, y equals 0. All right, and so we can see what those graphs look like when we change the amplitude and the midline. All right, let's take a look at 13.3, up, up, and away. So we still have this windmill, and the radius is 1 meter, and its center is 8 meters off the ground, right? So I'm gonna draw a little picture here. We'll draw it over here. So we have, all right, the point W starts at the tip of the blade and the farthest to the right. Okay, so here's W, and then there's some of the, there we go. All right, and then we know that the center is 8 meters off the ground. So that's 8 meters. And actually that is not proportional. Because if these are each 1 meter, these are 1 meter, the blades, so it's going to be more like that. All right, so it's 8 meters off the ground. All right, so we're going to write a function describing the relationship between the height of W in meters and the angle of rotation. So again, we're talking about height, so we're looking at sine, just like we were. So we have y equals sine of theta. So we're going to figure out what we're doing here. The radius is 1 meter, so that number in front is just a 1. It doesn't matter if you have that 1, you can put that there or not. And then we raised the entire thing 8 meters off the ground, so we're no longer starting at 0, 0. We're starting at 0, 8, right? So the center is actually at 0, 8. And so typically we would write y equals 8 plus sine of theta, just so there's no confusion that the 8 is being added to the theta. It's not. All right, so then graph the function using technology. How does it compare to the graph where the center was at 0, 0? So let's pull up our graph, and we'll graph that first one from the first problem, and then we'll also graph this one to see how they look different. All right, so we have y equals, and that first one was just sine theta, and then we had 3 sine theta, but we're just going to do 1. So sine was in our functions, sine, and then theta was in the alphabet, the keyboard, under P. So there is y equals sine of theta. And then let's take a look at y equals 8 plus sine of theta, right? And so it basically shifted that graph up. So let's pick up a pen. It shifted up 8 units. And then it says, what would the graph look like if the center of the windmill were 11 meters off the ground? Well, it would shift up higher. So shift up 3 more units. Because we're not doing any stretching or anything like that. All right. Here's the graph of a different function describing the relationship between the height, y, in feet of the tip of the blade and the angle of rotation, theta, made by the blade. Describe the windmill. And in this case, since that starting point is 30, it is 30 feet above the ground, the center. So the center is 30 feet above the ground, because that one's just been shifted up 30 units instead of 8 or 11 like the previous one. All right, and then you have your summary if you want to take a look at that.